Okay, so last time we were discussing about one functions, right? So we discuss about one functions or injective function. One function or injective function. So what is one function? So f from a to b is one if f of x1 is equal to fx2, then x1 is equal to x2, or x1 is not equal to x2, then fx1 is not equal to fx2. So this is what we discussed. So distinct points goes to distinct points in the codomain. So every function, given a function, it may not be one, but see, there is a difference between definition of function and one function. So onto function. So onto function or surjective function. Onto function is also called as surjective. A function f from a to b is said to be an onto function if for each y in codomain there is x in A such that fx is equal to y. So for every element in codomain, we can produce some element in domain whose image is y. Right. So for example, if my set A is 1, 2, 3 and B is A, B, C, D. So if I define a function from A to B, so suppose I map A with 1 with A, 2 with B, 3 with D, 2 with B. So is it onto function? So 1 map to A, 2 map to B, 3 map to D. Is it onto function?
No.
Not onto, right? Because so this function is 1, right? But not onto. Why? Why it is not onto?
Because there is not
Uh,
because there is no pre-image of C in A.
or y is equal to c in B, there is no x in A, which is pre-image of C, right? So But if I define another function, so 1, 2, 3, 4, right, and suppose my set B is A, B, C, and I define a function 1 goes to A, 2 goes to B, 3 goes to C, and 4 goes to C, right? So 1 goes to A, 2 goes to B, 3 goes to C, 4 goes to C, right? So is it onto function?
Yes, sir. Yes, sir.
Right, because every element in codomain have pre-image. So this is onto. Is it 1 1?
No, sir.
No.
Not 1 1. Because two distinct elements 3 and 4 have same image. Right, so that you can understand, and therefore what we can say about more about onto function. So thus a function f from A to B is onto if for each element y in B there is a preimage. There is a preimage x in A for y. Right, so for each element y in B there is a preimage x in y. So every element in codomain must have preimage. So therefore if f is a function from A to B, then what is range? Range of f is fa, right? What is range of f? What is the range of f? If A is a set and B is another set, right? And our function is from A to B. Do you know that range of f is f of A? It is subset of codomain. Am I right? It is a subset of codomain, correct?
Yes, sir.
Right. And therefore, if this is range of f, that means what about point which is not in the range? Suppose I have this point. What is the range? Range means the images, all images, images of all elements in domain. Right. So this is a range. This is range. That means the point which is not in the range, which that means it is outside the range. For this element, there is no preimage, right? Do you understand? Correct?
Sir, could you share the screen once again, please? I'm not able to see it.
You are not able to see the screen.
Yes, you're sharing the screen, but I'm not able to see.
Okay, I will share it again. Can you see the screen now?
Yes, sir. Thank you.
Yes. So if range is this, then range is a subset of codomain. And if situation is like this, key range is inside codomain B, then if there is some point outside the range, it may happen, right? There is a point outside the range, but for such point Y, there is no preimage, correct? Right?
Yes, sir.
Right. So therefore if f from A to B is onto, then what can we say about range?
Range must be equal to codomain.
Right, then range of f, that means f of A must be equal to whole of the codomain, because such situation not should not arise. Ki say there is something outside the codomain range. So if situation is like this, if this is A and this is B and this is function f, so if situation is like this, so range is whole of the uh, codomain, right? Then there is nothing outside the range, so that there is no problem for there is no such kind of situation key point element do not have preimage, right? So range should be whole of the codomain, right? So then we say that function is onto, right? So definition is clear,
Yes, sir.
right? So for example, if I define function from R to R, f of x is equal to x, then is f onto is f onto okay, so f of x is equal to x. Is it onto?
Yes, sir.
Yes.
No, there
Why it is onto? Because for
Yes,
any y in codomain R, because codomain is R, for any y, what is x? X is same as y. Choose x is same as y. Then what is f of x? Is f of y, which is y. So as it is, right? But what about this function f of x is equal to x square? If we define
This
f,
is not onto.
right, and f of x is equal to x square. So this function is not onto because uh, can we produce x can we produce x in R for every uh, so for any y in R in codomain, can we produce x in R? So for y in R, we produce x in domain such that f of x is equal to y, right? Is it possible to produce for any? So in particular, if y is equal to, for example, -1, does there exist x in R such that f of x is equal to -1, right?
No.
Right.
no, sir.
That is, does there exist x in R such that x square is equal to -1? And answer is no, right? Because there is no real number whose square is -1, square is negative, because we know that square of every real number is always non-negative, correct? So therefore this is not possible. For any y in codomain we cannot produce x which which is pre-image of that y, right? But if I modify my function, right, so f from R to R, R to positive non-negative real number. So if I define f from 0 to infinity, so f of x is equal to x square, same function, but I have just modified my codomain. So just modified codomain, then uh, is it onto?
Yes, sir.
Yes, sir.
Right, so in this case it is onto. And you can write down all the details because no negative number is there. So for y belongs to 0 to infinity, y is greater equal 0. So there exists x. And what is x for y? What is the exact value of x corresponding to y? What is the value? For example, if y is equal to 4, then what is x?
Plus 16.
Right? X have two possibilities, plus minus 2. There are two possibilities for x. Certainly there exists x. You choose one of them. That is x is plus 2 or x is minus 2. Correct? Or if y is equal to 3, then what is x?
Plus minus root 3.
Minus root 3 and available, right? X is plus root 3 or minus root 3. You choose one of them, or both have the same image, right? So f of root 3 is 3 and f of minus root 3 is also 3. So there are two preimages, but no problem. An element can have two preimages, right? An element can have two preimages when we are talking about function. We are not saying it is 1, 1, right? So it may happen that there are two preimages. So in general, for any y, what is a preimage?
Square root of y.
Right, plus minus square root of y. There are two preimages, except y is equal to 0. If y is equal to 0, then only one preimage, right? Because what actually happening if you look at the graph of x square, right? This is a graph of x square. Then if you choose any y, because this is our domain 0 to infinity, so if you choose any y, there are two preimages. What are two preimages? Minus root y and plus root y. So these are two preimages for any y, but that is not a problem because we are not saying a key function should be 1, 1, so it is true, right? So if I define f from R to R, f of x is equal to 3x plus 5 is f onto. Is this function onto? Is this function onto? For example, what is codomain? What is codomain here?
Set of real numbers.
Real numbers. So for example, if I choose y is equal to suppose 7, can you produce preimage? Say what is x in R such that, right? What is the x in domain? Domain is also R, so that fx is equal to 7, right? So basically what we want x in R such that fx is equal to 7. That means what we want fx, what is fx?
3x plus 5.
3x plus 5 is equal to 7. What we want x. That
X.
is want x such that want x such that 3x plus 5 is equal to 7. That means what is x?
Is equals to 3 by 3.
X is 2 upon
3.
3, right? So therefore f of 2 upon 3 is equal to 7. So here we select particular element, but is it true in general for every y? Right, for one element we are able to produce pre-image, for some element that is not sufficient. Right, are we able to produce pre-image for every element in codomain? Right, so let y belongs to R, any. Now choose, just close your eyes and choose any element from codomain. Right, then want x in domain such that fx is equal to y. That means what is fx? Suppose x is a pre-image. We don't know what is x, but suppose it is a pre-image of y. Then what is fx? 3x plus 5. That should be equal to that y, the number y which we are looking for. That means what is the pre-image x? Yes.
Yes, sir.
Right. So suppose somebody gives you y. Can you produce pre-image immediately? Right. Suppose I give you y is equal to 350. Can you produce pre-image x? Right. What is x?
Yes.
350 minus 5 divided by 3. So this is actually formula to produce pre-image of any y. So just put value of y, immediately we'll get pre-image. Therefore, for y belongs to R, there exists x, which is y minus 5 by 3 in the domain such that f of x is equal to y. Now check that this is a correct pre-image. Right, f of x, what is x? Y minus 5 by 3. Is it is it giving does it gives us y? Right, but what is f of anything? What is f of x? F of x is 3x plus 5. So what is f of this number? 3 into this number, right, plus 5. What is it? 3 cancels, y minus 5 plus 5, so it gives us y. Correct? Is it correct?
Yes, sir.
If I define f from R to R, fx is equal to x cube, right? Prove that f is onto. So you check this, it is onto. So if I define f from R to R, f of x is equal to x square plus 2x plus 3, right? What is range of f? Is f onto. So you think about it. What is the range of this function? And is this function onto? Right? If I define function from R2 minus 1 to 1 and fx is equal to sine x, fx is equal to sine x, is it onto? Is this function onto? Sine x, is it onto or not onto? What is your answer? What is your answer? Sin x.
Yes.
Yes, right? Because, and proof is not very easy, but you should try to think about the proof. Right? Because if you look at graph of sine function, then 1 and minus 1. If you look at graph of sine function, then for every element between minus 1 and 1, you can produce many pre-images. Right? There are many pre-images for every y in between minus 1 and 1. Right? So these are pre-images. These all are pre-images of same number y. Correct? That you can observe from this. Fx is equal to log x. So f of x is equal to e raised to x. Is it onto? Okay, let me call it as g.
No, sir.
E raised to x. What is graph of e raised to x? Just see the graph. Try to sketch the graph of such functions e raised to x. And what is the range of e raised to x? If you define on R,
0 to infinity.
right? So range is 0 to infinity. And what is my codomain here?
0 to infinity.
Right? And therefore, if you define e raised to x from R to 0 to infinity, certainly it is onto, right?
Yes, sir.
Now, what about log function? You know graph of log function.
Yes,
So
sir.
domain is 0 to infinity. Log is not defined for negative numbers and 0, so 0 to infinity. And will it take all the real numbers? Will it take the values, all real numbers? So yes, because if you look at the graph is going towards the upper end going towards plus infinity, lower end is going towards minus infinity. So you should think about such functions. So yes, this function is also onto. Right. Now a function f defined from A to B is said to be bijective. A bijective function if f is 1 1 and onto. Right. So if function is 1 1 as well as onto, then such function is called as bijective function. Right. So if I define function from R to R, fx is equal to x, is f bijective,
Yes.
right? Because f is 1 1 as well as onto. So if I define function from R to 0 to infinity, fx is equal to x square, is f bijective. Is it bisective?
Yes, sir. Yes.
Is it 1 1?
No, sir.
Not 1 1, right? So not bijective. Correct? Is this function bijective? Third,
Yes.
right? Because
Yes.
our domain is now
Yes.
0 to infinity. We are not considering negative numbers. So every element has unique preimage. So for example, preimage of 4 is plus 2, not minus 2. Minus 2 is not available. But in this case, f of minus 2 is equal to f of 2 is equal to 4. And minus 2 and 2 are in the domain. Therefore, two distinct elements have same image. So not 1 1. But in third case, minus 2 is not there or negative numbers are not there. So it is bijective. Right. So f from R to 0 to infinity, fx is equal to e raised to x. Is this bijective?
Yes, sir.
Yes, sir.
Yes, right. You can think, look at the graph. Because e raised to x is 1 1 that we discussed earlier, and also it is on to 0 to infinity. So if I define fx is equal to log x, so is f bijective?
Yes, sir.
Right, so log x is bijective if domain is 0 to infinity. Right, exponential is bijective if codomain is 0 to infinity, because range is 0 to infinity. Okay, so now if I define a function f from integers to natural numbers, f of n is equal to n square, then is f bijective?
No.
No, right? What is the reason?
It is not 1 1 function.
Right, because f of minus 1 and f of 1 is 1, so not 1 1. Right, to prove that not some statement is false, 1 1 is fails, means what? One evidence is sufficient, right? There is a pair of two non-distinct elements whose image is same. But f is onto, right? F is onto, is it true? Is it true? F is onto. F is onto or not?
Yes, sir.
Yes, because you take any natural number, I can take its so for any m belongs to codomain, there exists n. What is n? There are two choices for n: plus minus square root of m. In integers, no. Is it onto? There is a problem. Is it possible?
No, sir.
No, right? So, can you produce preimage for every natural number? For example, for which natural number we cannot produce preimage?
3.
So 2, 3, you can think about this. There is no preimage. in Z, right? So for 2 in codomain, it has no preimage because its preimage would be square root of 2, which is not available in integers, right? So therefore not on 2. Not on 2. So this function from integers to natural number is neither 1 1 nor on 2. But it is a function, no problem. Right, so if I define function from natural numbers to integers, f of n is equal to n, right, is f11 is f on 2. Okay, is this function 1 1?
Yes, sir.
Yes. Right, because it is straightforward to see that it is 1 1, right? Because if you take two distinct elements m and n, right, suppose f of m is equal to f of n, that means m is equal to n, so then pre-images are also same. Is it onto?
No, sir.
No.
Right,
No,
it
sir.
is clear because for negative integers we cannot produce pre-image, right? If y is equal to -2, then there is no n in n such that f of n is equal to -2. So it is not possible, so not on. But question I would like to ask is, does there exist a bijective function from n to z or z to n, whatever? Does there exist a bijective function from natural numbers to integers? Okay, I will.
No.
Okay, let us think one more question. Let a is equal to 2k. K belongs to natural numbers. What is this set?
Set of even numbers.
Right? All even. Set of all even natural numbers. Right? Then does there exist a bijective function uh, from uh, a to n or n to a? Does there exist a bijective function from a to n or n to a or n to a? Same thing. What is your answer?
No.
Okay, so define a function g from natural numbers to this set A, even numbers, right? 2, 4, and so on, by g of n is equal to 2n. Now, is it 1 1 on 2? Is it 1 1 on 2?
It is one function.
It is 1 1. Why? So, how to prove that function is 1 1? Suppose I take m and n in n such that f of m is equal to f of n. Suppose images are equal, then can we prove that pre-images are also equal?
Yes, sir.
Right, so 2m is equal to 2n because f of m is equal to 2n. 2 cancel, so m is equal to n. Right, that
Yes.
means if images are equal, pre-images are equal. Right, for any m and n this is true, therefore what we can say, G is
1 function.
right. For example, 1 goes to 2, 2 goes to 4. That means distinct element goes to distinct element. So that is clear. Now is it onto? Is it onto? How to prove that it is onto? For example, if you look at 10, 10 is in A, correct?
Yes, sir.
What is its preimage in domain natural numbers? What is its preimage?
5. 5.
5. Very good. Can you produce preimage for every element?
Yes. Yes, sir.
Right?
Yes.
Let uh, M is in A, then there exists N. What should be the preimage?
N.
What is N? But we know M. M is given, right? We are given some element in. Suppose someone asks you,
M by 2.
right?
M by 2.
M by 2, right? Somebody gives you element in codomain and he asks you to produce preimage. How will you produce? You know what is element given to you. Using that element, can you produce preimage? So that is M by 2. And is it in set of natural numbers? What is the guarantee that m by 2 is a natural number? For example, 7 by 2 is not a natural number, right? But what is the guarantee that m by 2 is a natural number?
Because our
You
codomain
are
is even numbers.
Right. If you are choosing element from A and we know that all elements in A are even, so m is even, certainly it is divisible by 2 and so n is integer, natural number,
natural number.
right? So there exists n is equal to m by 2 n such that f of n is equal to m, right? And therefore f is onto. And so can we declare that f is bijection,
Yes,
Yes,
sir.
sir.
right? Therefore
Yes.
therefore f is bijection. Okay, so this was my second question. Now third question I would like to ask, because our main question is
Sir,
a hmm?
G is bijection.
Oh, so G is a bijection. So what we basically wanted to produce, our main question is, does there exist a bijection from natural numbers to integers or integers to natural numbers? Right. So we saw that there is a bijection from even numbers to natural numbers. Right. So does there exist a bijection from A? A means even numbers. Even numbers to natural numbers. Right. A means what? 2, 4, 6, 8, and so on. All even numbers to natural numbers. Does there exist a bijection?
Yes.
Right. So I can define a function phi from A to n. And what is that function? Can you tell me the function? 2, 4, 6. This is A, right? And what is n? 1, 2, 3, 4. And if you observe the sets, and what is the obvious natural map? Natural means there could be different functions, no problem. But what is the easiest? Naturally, we can see.
One
A is a sub.
If we map 2 to 1, right? Because I want map from A to N. So if you map 4 to 2, 6 to 3, then 8 to 4, this is a natural way, right? And why it is natural? Because how will you relate 2 with 1? Phi n is equal to where n should be mapped, where 2 should be mapped. N
N by 2.
n by 2. Very good. Right? That is what the reverse process in previous case. What was the reverse process? How to produce pre-image? Just divide by 2. Now here we want to produce image. So divide by 2 because this is a reverse process. Right. In previous case, g was a function from natural numbers to a. Now what is a phi? Phi is a function from a to natural numbers. So opposite process, exactly opposite process, right? In previous we multiplied by 2. Now here we divide by 2. Correct. Do you understand? In previous case we multiplied by 2, here divide by 2. So these two maps are opposite of each other. Then is phi is bijection. Do you agree?
Yes, sir.
Right. So you verify this. Phi is a bijection. And what is phi? Phi is a map from even numbers to natural numbers. Okay, I will now ask next question because we are going to achieve something which is a stronger result. So B is equal to right. What is this set?
Set of odd
number.
natural.
Set of odd number.
Right, all odd natural numbers. So does there exist a bijection from B to N? Does there exist a bijection from B to N?
No, sir.
Can you define a map? Can you relate elements? Suppose naturally if I try to map 1 with 1, right? 2 with 3, right? 3 with 2, 5 with 3, then 7 with 4, and 2k minus 1 with k. Is it possible?
No.
Define a map, for example, psi from B to N. And what should be the map?
Two k minus 1. Sorry, 2n minus 1.
Uh,
N minus 1.
See, I want to map 1 to 1.
N plus 1 by 2.
N plus, right, N plus 1 by 2. For example, under this map, where 1 will go? What is psi of 1? 1 plus 1 by 2, which is 1.
1.
Is psi of 2? 3. Where 3 will go?
2.
2.
Where 3 will go?
2.
2.
2.
Where 2k minus 1 will go?
K.
K. Correct? Is it correct? Is it correct? Is it clear?
Yes, sir.
Right. Now, then, is psi 1 1?
Yes.
Sir.
Right. So just take psi of n is equal to psi of m. Suppose images are equal, then prove that pre-images are also equal. Cannot have distinct pre-images, right? So psi of n is equal to psi of m. But what is psi of n? What is psi of m? Right? Simplify this. 2 cancels. N plus 1 is equal to m plus 1. 1 cancels. So n is equal to m. And this is clear from this figure, previous figure, ki we can map distinct elements to distinct elements actually. Right? Therefore, this function is 1 1. Is it onto?
Yes, sir.
Is it onto S? Why? So for
Reverse process.
right. So for what is the reverse process? What is n? Such that right. So if you choose any element from codomain, what is a pre-image in domain? So for so what we want n in B such that psi of n is equal to m. We have selected any element from codomain and we want to produce pre-image in domain. If you are successful, then we are done. Correct? Can you tell me the pre-image? What we want actually? What is psi of n?
N
Am I
plus
right?
1 by 2.
So what is n?
2m minus 1.
m minus 1. And therefore, for any given m, there exists n. What is n? 2n minus 1 in B such that f of n is equal to m. You check this. If I put n is equal to 2m minus 1 in this formula, then we'll get m. Right. So if you look at this previous figure, then what is the pre-image of k? If this is a way, then what is the pre-image of k? 2k minus 1. That we directly see, right? So therefore, what is the pre-image of m? 2m minus 1. Is it clear?
Yes.
And hence, psi is a bijection.
Can you just scroll up?
Which part you want to see?
Yes, sir, this one.
Yes.
Yes, sir. Done.
Okay, so now just observe the situation. So what we what we did so far. So what is the situation? If A is equal to all even numbers and B is equal to all odd numbers, right? Then there exists phi from A to N, right? And psi from B to N bijections, right? So both are bijections. So okay, so what I have, what is the current situation? Okay, natural numbers. Can I say that natural number is union of A union B?
Yes, sir.
Union of A and B. Now, and what we discussed so far, there is a bijection from this to this. There is a bijection from this to this, right? Just observe this picture. What is this? 1, 2, 3, and so on. What is this? 1, 2, 3, and so on. Okay. Now I will consider another set. What is that set? Minus of n. Minus 1, minus 2, minus 3. Correct? Now, does there exist a bijection from this set to this set? Let us call this as minus n, negative of all natural numbers. Does there exist a bijection? Does there exist a bijection from n to minus n? What is your answer?
Yes, sir.
Just,
Yes, sir.
just map 1 to minus 1, 2 to minus 2, right? So you can say that eta from n to minus n. What is eta of n is minus n, right? So this is then eta is a bijection, right? So now question is, what is integers? What is set of integers? Union
Union of A9 minus N.
union 0,
0.
right? Now question is, does there exist from, this is a big question, and just observe the previous discussion. Okay, what is n? A union B. So from A to this positive integer and B to negative integer, there is a bijection. Only problem with 0. So how to work out it? The question is clear.
Yes.
Okay, so you just think about it. Next time we'll try to discuss about this map. What is a bijection from natural numbers to integers? Just recall our discussion and then try to answer this question. Next time we'll discuss it. Not a problem.